What do we know about it? Look at it first, see what indications or markings. Does it have anything? It says it's fragile. It says to face up.
From Toronto, so it's Canadian. Yep, it arrived at Rosebud. Whoa, here, Proto Cycler. It has there's a hand crank on the side of it. Proudly made in Ontario. Canadian, okay. Maybe
Let's get some photographs of this too. Somebody has a camera, can take photographs for stills while I'm doing the broadcast.
Here we go.
Well, let's get it open. Let's figure it out.
Okay.
Somebody else maybe, what would you do to find out more about it? I mean, we have some other resources besides our hands and knives and stuff.
Smell it.
Like maybe the internet, maybe start looking up what it is.
Whoa, what is going on right here? Oh my gosh, I feel like Christmas Day. Wait, also, could you open up this for me? Here we go. Whoa, Proto Cycler, Pro Cycle, I like that.
Yeah, like that.
Okay, breaking down the vernacular. Here we go. Oh, it's heavy.
Wouldn't one of you get on the computer and start using the Oracle to figure what this thing is?
Proto Cycler?
I mean, right on the big screen. Yeah, yeah.
Oh, here we go. This is a cord, all right? So it plugs in, all right? So we're using electricity, it looks like. Wonderful.
We have plastic bits.
Here we go.
Oh, what does that? What is
Plastic
PLA?
bits. PLA. Oh my gosh. Do you have someone
Wait a minute,
who's
is that
able to search
Palestinian Liberation Action Group?
I think so, isn't it?
PLA?
Palestinian. Oh my gosh. Oh, we have some more. Is that some more PLA right there? So we have some tools. All right, self-reliance.
Oh, I see something on the screen that Caitlin brought up. Oh, it says, I'm sorry, I was wrong. It's down from 6,999 USD on sale for 3,999.
Oh.
And then there's the shipping. So I probably wasn't off on the 4,500 since it's really $4,000.
Extruder on the market.
The most advanced desktop extruder on the market, revolutionary extrusion hardware and digitally regulated filament diameter control, level extrusion control with experimenting with polymers and additives.
Polymers. What's a polymer?
Note, the Protocycler Plus does not have the mechanical grinder. Does this one have the grinder? I think this one does have the grinder because this is not the Plus.
The Proto Cycler Plus. It is.
Oh, does it have a grinder? It does not have a grinder. Yes, it does have a grinder.
Is there a grinder in there?
There's a grinder, yep.
Okay.
This is what we got before we got the precious plastic shredder. We purchased this and we found it was such a pain to shred plastic by hand. And then the shredder broke and then we had to return it. And then it took a year and a half to get it back. They had staffing issues, COVID, all sorts of problems, and it finally came back to us. We bought the original one for $2,000. They sent back the one that's now $4,000.
Oh, wow.
So we actually, thank God that they have a wonderful CEO. He wrote back personally apologizing for the year and a half delay in getting it back to us for the defective unit and said, we're upgrading you to the Pro version, which is $2,000, and you don't have to pay that. So God bless him and his company.
Wow.
So it actually worked out to our favor.
Check
We,
that out.
yeah.
I might need some help, Austin. I'm not really sure. Maybe
Going all the way out.
Yeah, but it's pretty heavy in there.
It is very heavy, and you don't want to damage it. It should stay upright the whole time.
Should we turn the box on its side and then slide the box
Why don't you
off?
cut the box down?
We can. Do we have a cutter? I do.
I did right here.
Oh, there we go.
What is
The
it?
Protocycler pays for itself. It'll save you money on material costs and lower your ecological footprint. Make filament in exactly the quantities you need and recycle any 3D prints and waste you no longer need. Save up to 80% of the material costs of 3D printing.
Is this living it here or at Rosebud?
Here.
Okay.
We had it at Rosebud and we tested the first one there. And when we called the techs after it broke and we tried to fix it, troubleshooting, they said, what environment do you have it in? Now, this has nothing to do with why it broke, but they said you're getting bad prints on your printer because the moisture in Florida in an un-air-conditioned space causes the plastic to absorb moisture. And so we have the Ultimaker S5 $5,000 printer that I got for this class. We moved it from Rosebud upstairs where the microscopes are You saw it just now, you and Kaylin and Michaela saw. So we have a $5,000 3D printer with a variable heated bed, so we can use different polymers. And the idea for this class was we would get a protocycler that is experimental, that lets you do not just PLA, which is what everybody prints with, but also we can experiment with HDPE and LDPE and PETE. And we tried that, and then the machine broke. So we didn't get very far. One student did their capstone on this machine before it broke. So the idea that when 3D printing is normally done, so much of the material goes to waste because you print a scaffolding to hold the 3D print together, and then you snip that off or dissolve it, and then it goes to waste. So this was to turn it back into 3D printing filament.
Check this thing out. Should we break down on all sides? Or you just...
There you go. That'll be enough.
Yeah, this is very precious. So now you guys have a $5,000 3D printer and a $4,000 filament extruder. If we can't do something here,
Here we are.
and this one does have the manual grinder, but like I said, manual grinding is a pain. It's labor and time. So we ended up getting the grant to get the precious plastic shredder that now we're repairing, that Alan's. You're meeting with Russell Watrous tomorrow at the engineering lab. Do other people in the class know about it? Because they may want to come. It's at 9 a.m. Tell them.
Yeah. So I'm gonna meet with Russell at the Department of Engineering, the machine shop they have, and bring the shaft to them and make orders. They will help us to fix the shaft or make a new one for us.
Wow. So you've already talked to them and they seem to be agreeable?
No,
No, you haven't met them yet.
no,
Oh, this is a cold call? They didn't even know you're coming?
no.
Oh,
Just bring the shaft and in person walking and ask them maybe they can help or not.
how do you even know that they're going to be open?
They have open hours on the internet, on the website. Yeah.
And what do you know? On the website, did it say about walk-ins? Did
Yeah,
it-
they have the requirements to print out the drawings or the shaft and walking to
Mhm.
the e-machine shop, and they will help us to fix it or build one new. Mhm.
Oh, wow, okay. So you've done everything that they need you to do in order to
Yeah.
qualify.
Mhm.
So we might be able to make our shaft here, and then the new shredder we want to build with a double axle, they might be able to help us build that too? That's your hope?
I think so, yeah.
Okay, good. That's exciting, and I'll tell you a little story in a second about an ally that we met at the Dunedin Hope Festival. Warning, we
Only
have
put
made every
plastics
effort
that
to
you
make
know
this
what they
product
are.
as safe as possible if used correctly. Failure to follow the safety guidelines and read the manual could result in serious injury or death. Never extrude PVC, polyvinyl chloride plastic number 3. Never, because it's got what in it?
Chloride.
Chlorine, mustard gas from World War I. Like, you're not allowed it in mustard, so you'd never use PVC in this machine or any plastic whose type is unknown. The fumes could be lethal. Thanks and happy protocycling. So, yes, let's observe that.
Yes.
LDPE is fine. That's plastic bags, plastic number 4. You should all be able to rattle this off. HDPE is plastic number what? See what happens when you don't give students exams? They actually learn. No, but they learn when they need to learn it. So HDPE is plastic number 2. PETE, the bottles is plastic number? It's number 1. 3 is PVC, the one you can't use in this. Why are these numbers important? Only because when you pick up a plastic, they don't have the name, usually they have the number. So knowing the number will help you know, wait a minute, what is that? Is it PVC? It'll say number 3. If you said, 3 is PETE, and you put it in there and you die. So now it's a matter of life and death. All right, and so this is, what plastic number is this? Can we put this in the machine?
No.
Why? What is it?
Styrofoam?
Yeah, which is what?
6.
Number 6, polystyrene. Your body produces polystyrene. This can actually be eaten by waxworm larvae. They will eat it. It's a biological one, but of course, you don't want it out in our external environment. You want it to be put in a place where waxworm larvae can have at it. But yes, you can. We don't know how this will print. PLA, polylactic acrylic acid, or polylactic acid, is it? PLA, polylactic acid. Maybe look it up. There's, we got that right up there. Memorize these, you guys. Not for a quiz, not for an exam, but to save your life. Memorize them. 1, 2, 3, 4, 5, 6, 7. 7, of course, is useless. It's other. Doesn't tell you what's in it. Could be deadly. Might not be deadly. You know, it's just other. So be careful with number 7s. But you're pretty safe using 1, 2, 4, 5, and 6 in this machine. But this is not 1, 2, 3, 4, 5, 6. This is another. This is 7, but it's a very valuable 7. Doesn't have a number on it. It is made from cornstarch, I believe, or is it milk protein? Can you look up PLA?
Lactic is typically
Milk.
milk, but
But it's from the galactic, from the Milky Way, from the maybe it's just polylactic acid, known as polylactic acid or polylactide, is a thermoplastic polyester, so it is one of the PEs like HDPE and LDPE, made by the condensation of lactic acid extracted from children's muscles when they get exhausted.
that,
Runners, they get runners. They chase them and then they produce a lot of lactic acid. They knock them down and extract it from their muscles.
not Michael Phelps, 'cause he doesn't make as much.
Michael Phelps doesn't make it right. Loss of water. It's popular material produced from renewable resources. It's the most highly consumed volume of any bioplastic in the world. I should stop reading, let you read. Which parts do you want to read? Loud, aloud.
PLA has become a popular material due to it being sorry, this, let me get over here so I can not crank my app when I'm looking at it. PLA has become a popular material due to its economically produced from renewable resources. In 2021, PLA has the highest consumption volume of any bioplastic in the world. Although it is still not a commodity polymer, its widespread application has been hindered by numerous physical and processing shortcomings.
Huh. Hey, don't tell us what those are.
Number 4.
Yeah, click on 4. That's interesting. It says polylactic acid, perspective on PLA-based sustainable materials for durable applications, focus on toughness and heat resistance, and maybe it doesn't have the toughness and heat resistance. Gosh, you guys are doing academic work while we're doing an unboxing. How's that for a model of education? Learn what you need to know when you need to learn it, then it sticks. I think it's much superior. All right, what do we learn here? Blah, 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 et cetera, et cetera. Not exactly. This is the concept of tailoring the properties of PLA to achieve stiffness, toughness, balance, along with acceptable heat resistance comes into play. So I guess that's it. It just isn't tough enough for most commercial products. But for prototyping, it works great. And that's why it is go back if you don't mind to the original doc you were looking at. Note that it said it is the most, after the 4,
PLA is the most widely used plastic filament,
Material and 3D printing.
there you go. Its low melting point, high strength, low thermal expansion, good layer adhesion, and high heat resistance when annealed make it an ideal material for this purpose. Without annealing, however, PLA has the lowest heat resistance of the common 3D printing plastics.
better click on annealed for those who don't know what annealed is. Heat treatment.
Heat treatment that alters physical and sometimes chemical properties of a material to increase its ductility
Yeah, the main
and
to
reduce
draw it
its
out.
hardness.
So in other words, you have to heat it above the recrystallization temperature, it says there. And so this is an annealing machine, basically an extruder. It has an auger down here, and the auger feeds it into a heating element down here. It comes out annealed, meaning ductile. It can be spread out and thinned out, and it comes out more pliable. And that's why it's useful for this, because when it's annealed, it has these better properties. But then the products are not commercially viable. They will break apart. So we use PLA for early prototyping. It's fairly cheap, and I think it is biodegradable. So if you go back, so annealing just means heat treatment, right? So you go down the potentially ambiguous, blah, blah, blah. Maybe you can type in, it's soluble in a range of organic solvents like ethyl acetate, which is low risk. It's basically like vinegar in a sense, but it's got an ethyl group on it. Keep going down, propylene polycarbonate, consumer goods, disposable tableware, cutlery.
Drug delivery. Oh, like pills.
Yeah. fishing line, good one for weed prevention, sandbags, planting pots, binding tapes, and ropes. Automotive parts, what about the biodegradability?
So it says that's, thanks to its biocompatibility and biodegradability, PLA found interest as a,
Polymeric scaffold.
for drug delivery purposes, and listed as biodegradable PLA cups.
End of life.
PLA is biodegradable under industrial composting conditions, starting with chemical hydrolysis process, followed by microbial digestion to ultimately degrade the PLA.
So it has to be up to 136 Fahrenheit. That's why our experiment at Rosebud,
It's not really.
not in our compost bins, because we can't get them. Well, you can. Thermophilic process in a good, well-designed compost bin can get up to 136, 140.
Look at number 4. Least preferred option on landfill because PLA degrades very slowly in ambient
Yeah.
temperatures. So
Yeah.
in a traditional composting, it's not going to do much
Right.
at all.
But since it does not contain chlorine, it does not produce dioxins or hydrochloric acid during incineration. It can be combusted with no remaining residue, so it's an environmentally friendly disposable way of doing waste PLA. So it can be incinerated or used as fuel, for waste to fuel. But recycling it, this is what this is. This is a PLA recycler primarily. That's how Protocycler started, doing a prototype for PLA recycling. And they called it Protocycler. But then when they realized you could program the heating element and the speed of the auger by plugging into the USB on this side, this is what our student did their capstone on, you could get it to slow down, speed up, heat up, cool down. We started working with bottle caps. The problem with bottle caps is they're made of HDPE number 2 or polypropylene number 5. They have a very low adhesion. They don't self-stick. This stuff self-sticks, so you can build up layer upon layer in the 3D printer, right? Bottle caps don't self-stick. So then we tried a 50% mix of PLA and bottle caps. That did work because this added the adhesion, and we're trying to figure out the right mixes of different polymers to get the properties you want. A teacher in, I think it's Idaho, unless Idaho is just in my mind from John Anderson's presentation, somewhere in the Midwest North, professor of waste science has her students doing 3D printing using PET, plastic number 1, which apparently has a high adhesibility. But I don't know her parameters because when I try PETE, it crystallizes. And I talked about the crystallization temperature just there. And all my PET recycling stuff with thermoplastic, it just cracks. So there's something that the student was working with a laptop, and you can control all the different parameters in this, which is why this machine is so expensive. It's an experimental machine. It has the readout on the computer, and you can just like dial in. And once you've figured out the right parameters, now you're ready to go to scale. So this is meant for people to experiment with different plastics. And the 3D printer we have with a variable heating bed for different adhesion is made for doing experiments also. So I got things that are for us to do lab scale work, not industrial work. So if anybody wants to dip into this, it is here. There should be a handle for turning the...
It's in this bag right here.
Let's go ahead and put that on if you can. I want to see if this thing works. To take this out and just see what it is. But did we learn enough about the bio? Go down where it showed the pictures of the different products made of PLA.
How do you get the presenting bar to go?
Oh, it's so annoying. You have to click on it and move it somewhere or something.
I think sometimes it goes away.
Yes, sometimes and then not all the times. It's such a pain. But where you had that, oh, it went away. I don't know what made it go away, but it did. Where was that article that you were just looking at? Yes, ABS is, so it's number 7 because they don't know how to classify it. It should have its own number, like it should be number 8. Right, PL8, and you'd remember it.
Is there any kind of
So it is not an unknown, it's not an other, but it is in there. Polylactic fibers, nylon, fiberglass, polycarbonate, acrylic. They're just all the others. And that's only because industry at this economic, in this economic paradigm haven't figured out a way to make money effectively because of the labor costs. And so that's why it's all called other. They just throw that to the landfill, but it doesn't mean it's not useful. And certainly now this machine is the recycler for PLA, so it should have its own designated label because people can recycle all the PLA all day long.
We're
in here. So go down, if you don't mind, to the pictures. And it showed, oh, there. Those cups are what we used at the Dunedin Hope Spot Festival this Saturday. And they gave me some, and I brought them back to Rosebud. We did some experiments with them in the fabric composting area, and they ain't gone anywhere.
Wait, Dr. Colhane, you need to get a picture of
Yeah.
Alan with the Allen wrench.
Oh, Alan. I don't have a way to take a snapshot, but somebody else could. I'm still live streaming. But that's Alan and his wrench. Yeah, you take that thing off there. Of course, that's all the human skulls they found from ancient civilizations were unbiodegraded PLA. In fact, ancient people were made of PLA.
That's what we're gonna do.
Yeah.
Too soon.
Into our bones.
Tea bags, that's what they're using in those tea bags. So we never liked those at Rosebud because we can't get PLA to degrade properly. But if we put it in this machine, we could then use the tea bags. So it's good to see that now we can start collecting the PLA cups, the PLA mulch film, the PLA tea bags, and the skulls of the dead humans. Plastic, it's people from Silicon Valley and from Beverly Hills who have plastic skulls along with their plastic breasts. All right, so we can now recycle those. That's good to know with this machine. If you open this up, that should just lift off, no?
Is it being held on?
Shouldn't be.
Oh.
Okay, so there's a double barrel grinder.
Ah, yes. Okay.
We're going to build a big one of those. They're much more effective because the teeth bring everything inside rather than having to jam it down. So this is a mini double barrel grinder. That's pretty cool.
Wow.
Then it has the plunger, just like we have on the other precious plastic machine. The thing that made this not work, and here's this tray that has to come out, but I don't know how we can get that to come out without breaking it. Oh, there it goes. Notice that the tray has those holes like we have in our precious plastic shredder, and they are the same size as the PLA pellets. So it's to turn PLA that you've used to make a print, and you had to sacrifice 30, 40, 50% of your PLA is in the scaffolding you chop off of your print. It goes back in here and it comes back, not as pellets, but as pellet sized. And then they can go right into here, and there's a grill here so that it doesn't get anything bigger than this in there. It's a little bit bigger. You have two sides there. And then it goes through. Now the grinder, that's not going to work. What we found is there is a magnetic coupling so that nobody injures themselves that only turns on when the power is on and the lid is shut, because there's a sensor somewhere in here. And when this thing is on, one of these teeth is longer than the other, somewhere. This one here, I guess. Yeah, that one there. It goes in a specific way because there's a slit there. You see that slit right there?
Mm-hmm.
You have to turn it so that this long tooth activates the sensor so that way it knows nobody's fingers are in there. So once this is in, then it's engaged because the sensor is tripped. You have to close this because there's another sensor thing here that goes into a sensor. So this has to be fully engaged. And now, would you please plug it in, and we can see if it works, because what we found the last time is that it didn't work. It was completely disengaged.
Oh, okay. So we can maybe move it right here.
Yes, just very carefully. Or put it on a table that has wheels. Just wheel the table over.
Oh. Oh.
Hold it. So they gave us some starter pellets here, packets. Oh, these are for colorant. Yeah, they also had red ones and blue ones. And what is this? Uh-oh. Oh, I know what this is. This is the arm that goes on the other side. There's an extruder that comes out and it catches and spools, and then you put the spool to catch the new filament, because you have to wrap the new filament. It makes 3D printing filament as it comes out of the heated head here. And then there's air jets, and these are optics that optics that shine a light to make sure that the filament is good. Please detach spring when not in use. Right, the spring here gets put onto there, Then you want to detach it. So a lot we have to make sure. It says read the manual. And there's a guide there. There's the manual. So we don't have to worry about setting that up just yet, but we do want to try out this grinder. Go ahead and plug it in.
Moment of truth.
Moment of truth. Okay, so the moment of truth is there. There should be an on button on the back.
Yep. Here we are.
Yep. Da-da-da. Okay, lights on. It says extrude, settings, connection status. Now, we're not going to do an extrusion because we haven't set up the arm and put this spring on here and all that. We don't want to touch that. We don't want any dust to get on it. So we close this. But I do want to see if this engages. So would somebody turn that? And we'll look and see if the shredder engages or not, the clutch of the shredder. That's backwards. That's forward. Does it feel like it? I do see motion.
It's very slow.
It is very slow. Okay. I doubt any of you are going to spend time hand shredding. I think we should come up sometime. We'll get some plastic PLA cups. We will shred them up by hand, and we will try them at some point in the shredder. And then you'll say, gosh, that's a lot of labor. I'm bringing it up to Rosebud and fixing the darn machine and then letting electronics take care of it. Because the human labor is there. But it is gratifying to me to know that out the gate, I feel the motor engage. You can actually feel the magnet kick in, and it is working, because when we first bought it, this was the first piece that was broken, and there was no motion. It would always disengage. So I think, huh? Yeah. Oh, I see. So you mean, okay. Yeah. Yeah, good idea.
Oh wow.
You do the whoa, a little bit bigger. That second one.
Is it turning?
Yeah, just very, very slow.
Yeah.
You see it turning?
Mm-hmm.
I feel the resistance.
Do you want me to hold the camera and you can see?
I see it.
Yeah.
Okay, so that is working. And see how the double barrel works so much better to pull the stuff into the center rather than the one that we have right now. And then they're not going to make them anymore with the shredder. This is probably the last unit because they've had so many problems with the shredder. But if you don't shred, you can't use it. So for people who are serious about this, they buy shredders like we have, and then they use the protocycler just to make the filament. But pretty exciting. Okay, so I don't know if we should go ahead and set this part up now. Nah. Let's use our remaining, 10, 15 minutes. I want to show you the end of that lecture. And then so let's turn this off, and then at the end of class, we'll take it upstairs. And then next week, we will finish setting it up and try to actually use it. Okay?
Good.
All right. Thank you for unboxing. That was exciting. If you can unplug that and put that away. And yes, we'd love to hear your thoughts and comments. If you're a protocycler user, please share your knowledge. We'll share ours with you. And let's get this recycling thing happening for all the number 7s, particularly the PL8, as we like to call it. All right. Ciao for now.